Alright, let's continue with horizontal spring. Okay, and for case A, at the spring, the horizontal spring at equilibrium position. What does that mean by equilibrium position? Means that the spring are not moving. Okay, as you can see here, X at center of the mass. From the center, we take the X. Alright, so X equal to 0 means that at equilibrium position, the origin position of the spring. Any spring has a natural length at which it exerts no force on the mass, which is known as M. Alright, so the position of the mass at this point is called as equilibrium position because at that time the springs are not moving. Alright, not stretched or sketched. Let's proceed with B. Okay, when the spring is stretched, means that we pull the spring to the right. So means at this point, the X is to the right. So that is why X here is positive because we stretch the spring. So of course, F will move in the opposite direction. When the F is positive, F will move in negative position because it already defined in a previous slide that simple harmonic motion represent which is F and X are oppositely directed. As you can see in the figure again, let's have a look at this one. So X is more than 0 because it's moved to the right. So means that X are in positive. Okay, so for case C, when the spring is compressed, now we compress the spring. Compress the spring means that push the spring to the left. So means at that time, X is negative. So when X negative, F will positive. Alright. So then, as you can see here, X is negative. We can move to the left. So means that X here should be negative something. So F in a opposite direction. So this one is X equal to 0. The origin of position of the X. This one is the new position of the object. So this one also same. This is the origin position of X. This one is a new position of X. Alright, positive. This one is X is negative. Right. So from there, the spring exerts a force on the mass that acts in the direction of returning the mass to the equilibrium position, which is called as restoring force. So force here will play as a X in the direction of returning the mass to the equilibrium position. So the displacement is measured from the equilibrium position. Alright. So it means that if let's say you want to find a new displacement here, so we need to calculate from origin. Okay, origin position to the new position of the mass at the center. As you can see here, okay, I put the bracket. Okay, the X, I take the value of X from the middle of the mass, center of the mass. So means that this is the X, a new X here. Okay, so this same goes here, origin to the new X. So this is the X, which is positive. We don't know what is the value. Alright, so the force exerted by the spring depends on the displacement according to equation below, as we have looked in previous slide. So we know that F is always opposite direction toward the X. That is why there are negative sign here. So this one represent the Hooke's law, right? So F here, F represent the force, alright, of course in Newton. Negative is opposite direction of F and X. K is a spring constant or spring stiffness, alright, Newton per meter, the unit, and X is the displacement. So the unit, SI unit should be in meter. This one Newton per meter, this one is meter. Alright, so this one is Newton. Okay, again, we continue with Hooke's law. This one is Hooke's law. Right, so the minus sign, okay, I already mentioned earlier, on the force indicate that the restoring force means that the force applied in the object to move the spring back to the original position is always in the direction opposite to the displacement. The force is not a constant, so the acceleration also is not a constant because of this one from the equation of F equal to ma from Newton's second law. Still remember Newton's second law? Alright, so if let's say force is not constant, acceleration, so do acceleration. Alright, so this line here represent equilibrium position. Alright, when you stretch the spring, okay, it will move to the right, but F will move in opposite direction to the left. When we compress the spring, all right, so the position will move to the left, which is a negative, X will be negative, but F will be positive for compress. All right, so make sure you understand about the Hooke's law here.